All right, we're going to get going through the Chapter 4 review here, and we're going to do this in a handful of parts. So we're first going to start off, this part's going to go questions 1 through 4 in the graphing part of the review. So I'm going to do it on this sheet, but if you have your review handy with you, I'm just going to go through kind of A through I here on all 4 graphs and kind of put it in each little section here. So for the first function, we have f of x equals 7/4 2 to the x minus 3 minus 5. Okay, so it says for each function, if possible, find f of -2, f of 0, f of 4. List the parent function for each and state transformations of the parent function. List domain and range. List asymptotes. Sketch a graph. State where each function is increasing or decreasing. State the end behaviors, find the inverse, and approximate the average rate of change on the interval 2 to 5. Okay, so there's a lot of things going here. So I'm first going to start off by sketching the graph. Okay, so we start with the parent function, and the parent function is 2 to the x. We go through our HBAK that does all the parent function transformations. Okay, so our parent function is 2 to the x. So this up here is our minus 3. So that says go right 3. There is no b, capital B. That would be right here. We don't deal with those really on exponential or logarithm because the big base takes care of that. So there isn't one of those. A is here out front, and because this is bigger than 1, it's actually going to be a vertical stretch by 7/4. Okay, so we're multiplying those y values by 7/4, and then the minus 5 goes down 5. Okay, we'll fit in our domain and range here after we graph. We have the asymptote here from our graph. Okay, so our parent function is 2 to the x. So that table, our xy table, are 5 ordered pairs that we're going to graph. We'll start with -2, -1, 0, 1, and 2. So if I plug in -2, that would be 1/4, and then 1/2, 1, 2, and 4. Now remember, if we were doing logarithm, it would be backwards, the inverse of that. Okay, so I'm going to graph those in a different color here. So -2, 1/4. -1, I did that wrong. -2, that's positive. 1/2, 0, 1, 1, 2, and 2, 4. Ignore those points down there. Those were a mistake. So here's my parent function. My parent function starts with a horizontal asymptote right here at y equals 0. And these are the points I'm going to move. So I'm going right down through this HBAK. So start here. I'm going to go right 3. 1, 2, 3. Vertical stretch by 7/4. Okay, so that means I'm taking the y value. So 1, 2, 3. I was right here. I'm taking the y value and I'm multiplying by 7/4. So 4 times 7/4 is 7. So this goes to 7. So that's 4, 5, 6, 7. So we're here and then down 5. 1, 2, 3, 4, 5. Let me get a different color for these. Right here. Okay, so here we're going to go right 3. 1, 2, 3. Multiply by 7/4. So 2 times 7/4 is 7/2. So it's 2, 4, 6, 7/2, and then down 5. 1, 2, 3, 4, 5. Okay. 1 So we go right 3, 1, 2, 3, multiply it by 7 over 4. So 1 times 7 over 4 is 7 over 4, which is almost 2. So right here, and then down 5. So 1, 2, 3, 4, 5. Before I do the other points, we also need to do this with our asymptote that started right here at y equals 0. So I'm going to move it to the right 3, and when you do that, you don't see it. Vertically stretched by 7 over 4. Well, 0 times 7 over 4 is still 0, and then you go down 5. So 1, 2, 3, 4, 5. So here's our asymptote right here. Okay, and that dictates where our end behavior goes. So I do have the asymptote, which is y equals minus 5. I have 1, 2, 3. Let's do a fourth point here. So a half. So I go right 3, 1, 2, 3. I multiply a half times 7 fourths, which is 7 eighths, which is a little bit less than 1. And then I go down 5. 1, 2, 3, 4, 5. So about right in here. And we can kind of see where this is going. So connect our dots here. That's going to go that way, and this is going to go up this way. Okay, so our domain is negative infinity to infinity. Our range is going from negative 5 to infinity. Remember that parenthesis on negative 5 there, to infinity. Okay, let's see what else. We need to find the values of f of minus 2, f of 0, and f of 4. And sometimes you can find those by what points you plugged in. So 1, 2, 3, 4. I have that point. You may not know exactly where that point ended up because with 7 fourths, it's probably going to be a decimal of some kind. But we can also just plug those values in. So 7 fourths, 2 to the negative 2 minus 3 minus 5. And then 7 fourths, 0 or 2, to the 0 minus 3 minus 5. And 7 fourths base 2 of 4 minus 3 minus 5. Okay, so show us that you've plugged those in. Again, this would be your y-intercept, which I don't necessarily have. And this would be positive 4, which we said we kind of had that one. Maybe that's about negative 1.5. And then negative 2, we don't have that either. So when we can plug, now that we've shown we've plugged it in, we can type that into the calculator here. And we'll have 7 fourths, 2 to the negative 2 minus 3 minus 5. So this is negative 4.95 about, because I rounded that. And then this would be 0 minus 3, which is about negative 4.78. So 4.78, that's about where we ended up. And then plugging in 4 is negative 1.5, which is what we kind of said there as well. Okay, so we found those 3 points. We listed the parent function and all the transformations. We got the domain and range. We got the asymptote. We sketched the graph. Okay, so is this thing increasing or decreasing, and on what interval? So this thing is increasing from negative infinity to infinity. Decreasing, it is not ever decreasing. So everywhere it has a positive slope. Even way out here where it is just a very small increase, it is still increasing the entire way. State the end behavior. Okay, so as x goes to infinity, f of x goes to, okay, so as I go to infinity this way, as I go this way, your y values are going to positive infinity. As x goes to negative infinity, f of x goes to, okay, so as I come this way across the graph, your y's become a constant really close to minus 5. Okay, so these approach minus 5. Okay, so we got in behaviors. Find the inverse. Okay, in order to find the inverse, we're going to switch our x and y, and then we're going to resolve it for y. So I'm going to go ahead and switch colors here. So I'm going to switch x and y. So this would be x equals 7/4 2 to the y minus 3 minus 5. Okay, now I just need to solve it for y. So I'm going to add 5. So x plus 5 equals 7/4, 2 to the y minus 3. Then I'm going to divide by 7/4 or multiply by 4/7. So this would be 4/7 x plus 5 equals 2 to the y minus 3. Now I have to get it out of exponential. So in order to get it out of exponential, we put it into logarithmic, which is just using the definition and rewriting it. So we would have log base 2, and we can distribute this as well, of 4/7 x plus 20/7. So log base 2 of that equals y minus 3. And then you just have to add your 3 over. So your inverse, f inverse of x, equals log base 2 of 4/7 x plus 20/7 plus 3. Okay, so there's your inverse. And the last thing we need to find is the approximate average rate of change from 2 to 5. So your average rate of change will equal your f of 5 minus f of 2 over 5 minus 2. And you can do it the other way around. You can say f of 2 minus f of 5 and then 2 minus 5, as long as these two match up. Okay, so we didn't find any of those. So on bottom, 5 minus 2 is 3. On top, we're going to plug in 5 and we're going to plug in 2. And if you're using the y equals function in your calculator, you can just use the table for some of these quick values. So we have 7/4 2 to the x minus 3 minus 5. And when we go to the table here, we can just punch in 5. And then you get 2. And then punch in 2. You get minus, so negative 4.125. Okay, and then you need to calculate those. So 2 minus negative 4.125, 6.125 over 3 divided by 3, and change it to a fraction if you can. So math fraction, 49/24 is your rate of change. I like to put it into a fraction because this is a slope, and we're going from 2 to 5 up here, and that's the slope between those 2 points. Okay, there's the first one. The second one, if you need to pause or re-watch at any time, feel free to do that and go over and over and over this. The second equation here is f of x equals negative e to the x minus 1 plus 1. Okay, so we're going to kind of go through the exact same process as we did the first one. So we want the parent function, which is e to the x. We have h, b, a, k, d, r for domain and range. So h, we have an h here, and that's going to go right 1. We have no b here. Okay, this is an a, so this is going to go over the x-axis with that negative, and then up 1. Okay, so for this parent function, we have our table of values here. And then we're going to just do the same starting values. Okay, and remember, e is a constant. And e is actually right here on your calculator. It's connected to ln because they're inverses. So then we can have e to the negative 2, which is 0.135, e to the negative 1, 0.368, e to the 0 is 1, e to the first is 2.718, and e squared, e squared is 7.389. Okay, so I'm going to graph these points. And remember, these are rough estimates. So we're just trying to get into the right location. So here, and then here, 0, 1, 1, 2.718, about in there, and 2, 1, 2, 3, 4, 5, 6, 7, 3, somewhere in there. Okay, so those are my parent function points, and I'm going through through my HBAK. Okay, so start here. We're going to go right 1. We're going to go over the x-axis, so flip it over. So it's at positive 7.38. Then it's going to go negative 7.38. And then we go up 1. So about here. Okay, we're going to go right 1. We're going to flip it over. So you got your fraction, and then 1, 2, 1, 2, and then your fraction. And then we're going to go up 1. So about here. 0, 1, we're going to go right 1. We're going to go over, and then we're going to go down, up 1. Okay, don't forget we got to do the asymptote as well. So now's a good spot to do that. So here's our asymptote, this x-axis. So we're going to move it right 1. You don't see that. We're going to flip it over the x-axis, but you can't really do that because it is the x-axis. And then you're going to go up 1. So you have this asymptote right here at y equals 1. So if we kind of come back here to our asymptote, we have y equals 1. And we can kind of see that that's where my points are going. So we'll move one more point. We're going to go right 1. We're going to flip it over, and we're going to go up 1. So about here. So connecting the dots here, we get something about like this. And again, I want to see those points there and where they are, not just putting it in on your calculator and using the table. I want to see that you're moving those points. Okay, our domain and range. Our domain, since this is exponential, is all reals. Our range would be negative infinity to positive 1. Okay, let me pull this out here so we see where we're at. So where is it increasing or decreasing? So if we look here, this is always falling. It always has a negative slope. So it is never increasing. It is always decreasing. Our end behavior. So as x goes to infinity, or as x goes to the right, your y value is going to negative infinity. As x goes to negative infinity, so as we go to the left here, your y value approaches 1. So f of x goes to 1. And these should match your domain and ranges for these. Okay, so just double check that. We have our asymptote. We want f of negative 2, f of 0, f of 4. So plug those things in. So we have negative e to the negative 2 minus 1 plus 1. Negative e to the 0 minus 1 plus 1. Negative e to the 4 minus 1 plus 1. Okay. Again, we can kind of use the y equals. I want to see that you've plugged it in. So e to the x minus 1 plus 1. Look at the table here. So I plug in negative 2, I get 0.95. Plug in 0, I get 0.63. I plug in 4, I get negative 19.1. Okay, and you can use these as ordered pairs for your graph as well, but definitely want to see the transformations as well. Okay, so next would be the inverse. So to find the inverse, we switch x and y. So we have x equals negative e to the y minus 1 plus 1. And we're going to solve this thing for y. So we're going to subtract 1. So x minus 1 equals negative e to the y minus 1. We're going to divide by negative 1. So that's negative x plus 1 equals e to the y minus 1. Rewrite it in logarithmic. Now our base is e, so we're going to be using ln negative x plus 1 equals y minus 1, and then add your 1. So f inverse of x equals ln negative x plus 1 plus 1. Okay, so there's your inverse. And the last thing we have to find is rate of change. And that was from 2 to 5 was your rate of change. So that's, again, f of 5 minus f of 2 over 5 minus 2. So using our table here, f of 5 is negative 53.6. F of 2 is negative 1.72. And 5 minus 2 is 3. So when I combine those, sorry, I didn't know glare there. I just looked at the table here. And we can kind of double check our graph here. It looks similar. Okay, I plugged in 5 and I got that number, and I plugged in 2, I got that number. So negative 53.6 minus negative 1.72 is negative 51.88 over 3. So divide by 3, math fraction. So it is negative 1297 over 75, which is about negative 17.29. Okay, so you can have the fraction or decimal. I prefer fraction. Okay, so there's the first two. Let's look at the next two. Now these two are logarithms, so they're going to be a bit different. So f of x equals log base 3 x plus 4 plus 3. And I move this 3 to the back. Okay, so we've got our parent function, which our parent function is log base 3 of x. H, B, A, K, domain range. Okay, so we just have the 4 and the 3. So H would go left 4, no B, no A, and then up 3. Our parent function ordered pairs. Remember, this is exponential 3 to the x, and we're flipping that. So we've kind of talked about it in class, how to quickly find these parent function ordered pairs. So that's 1 over 9, 1 over 3, 1, 3, and 9. And that matches your negative 2, negative 1, 0, 1, and 2. So those points, so 1/9 negative 2, 1/3 negative 1, 1, 0, 3, 1, and 9, 2. These are the 5 points that we're going left 4 and up 3. So if I go left 4, 1, 2, 3, 4, up 3, 1, 2, 3. Left 4, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And then the last one, 1, 2, 3, 4, 1, 2, 3. You actually, with your parent function, have a vertical asymptote, which also goes left 4 and up 3. So 1, 2, 3, 4, 1, 2, 3. It's a vertical, so you don't actually see it shift up. And then here's the sketch of your graph. Okay, so your domain would be -4 to infinity. Your range is all reals. Okay, where is this thing increasing or decreasing? So if we look, it always has a positive slope going across here. So it is never decreasing. It is increasing, though, from -4 to infinity. Okay, it doesn't do anything below -4. In behavior, as x goes to infinity, f of x also goes to infinity because it's going up. As x goes to -4, okay, from the right side, because we can't go to -4 from the left. So we can put as x goes to -4 from the right, I note that with a little plus up there. As it comes this way, that thing goes to -infinity because it shoots straight down. Okay, so we have we need our asymptote. So our asymptote is this vertical line, so that would be x equals -4. Remember, the other ones were y equal because they were horizontal. We need to find f of -2, f of 0, f of 4. Okay, so that's log base 3 of -2 plus 4 plus 3. And log base 3 of 0 plus 4 plus 3. And log base 3 of 4 plus 4 plus 3. Now remember, you can't always put these in because our domain is -4 to infinity. So this in here has to be above 0. So if it's not, you would get an error. And we can, again, check our table here. So alpha table set number 5, I can put 3x plus 4 plus 3. Look at that table. And -2 would be about 3.63. 0 is going to be about 4.26. And 4 is going to be about 4.89. Okay, to find the inverse, we switch x and y. So we'd say x equals log base 3 of y plus 4 plus 3. So we're going to subtract 3. So x minus 3 equals log base 3 of y plus 4. Rewrite that. In order to get it out of logarithm, we need to rewrite it as exponential. So that would be 3 to the x minus 3 equals y plus 4, and then subtract the 4. So f inverse of x equals 3x minus 3 minus 4. There's your inverse. And then we'll come up here and do the rate of change. And that was from 2 to 5. Whoop. So we need f of 5 minus f of 2 over 5 minus 2. So that's over 3. Again, using the table, I already have the 5. So at 5, we get 5. And at 2, we get 4.63. So then if we calculate that, 5 minus 4.63 divided by 3, math fraction maybe. Yeah, 37 over 300, or about 0.123 for your average rate of change. Okay, last one here. And that last one is, again, I'm going to rewrite it into a better form. f of x equals negative log base 2 of x minus 1 plus 5. Okay, our parent function is log base 2 of x. H, B, A, K. Whoop. Okay. Domain range. So H would go right 1. B, there is no B. That'd be right here with the x. A would be here, so that's over x-axis. And K would be up 5. For our parent function ordered pairs, we would have 1/4, 1/2, 1, 2, and 4. And -2, -1, 0, 1, and 2 are kind of the ones we're always going to use. So when we graph that parent function, we're at 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. So we actually get to see all those. Okay, so we're going to take these points and we're going to go right 1. So right 1. Flip it over the x-axis, so down to -2, and up 5. So 1, 2, 3, 4, 5. Let me just do that again. So right 1, flip it over the x-axis, and up 5. 1, 2, 3, 4, 5. Okay, so right 1 over the x-axis, up 5. 1, 2, 3, 4, 5. Right 1, flip it over the x-axis. This one stays. And then we go up 5. 1, 2, 3, 4, 5. We're going to go right 1, flip it over the x-axis, and up 5. 1, 2, 3, 4, 5. Right 1, flip it over, go up 5. 1, 2, 3, 4, 5. Do the same thing with your asymptote. It goes right 1, flips over the x-axis, so it actually flips but lands on itself, and go up 5. You can't see that. So here's my vertical asymptote. So we connect the dots here, like so. Our domain would be 1 to infinity. Our range is all reals. For increasing, decreasing, this thing is going down over time and always has a negative slope. So it is never increasing, but it is decreasing from 1 to infinity. Your end behavior, as x goes to infinity, your f of x, or your y value, is going down. Okay, so it's going to go down forever, so it's going to negative infinity. As x goes to 1 from the right side, so 1 plus from the right side, your y value is going up, so it is going to positive infinity. Again, your end behaviors may match your domain and range. We said that we had an asymptote of x equals 1. Okay, we need to find f of -2, f of 0, f of 4. So we plug those values in. So negative log base 2 of -2 minus 1 plus 5. Negative log base 2 of 0 minus 1 plus 5. Now I can see right here I'm going to get a negative in here, and I can't have a negative. So no solution there. Okay, because remember, x has to be bigger than 1. So up here, I can't have anything there. So no solution. So negative log base 2 of 4 minus 1 plus 5. So did I have 4? 1, 2, 3, 4. It did cover that graph, so we'll plug that in and see where we're at. So I can change this. So negative log base 2 of x minus 1 plus 5. So looking at the table, when I plug in a 4, I get 3 3.415. And you can see here when I plugged in 0, I got an error. That means it wasn't in the domain. Okay, to find the inverse, we have x equals negative log base 2 of y minus 1 plus 5. So we're going to subtract 5. So x minus 5, negative log base 2 of y minus 1. We're going to divide by negative. So negative x plus 5 equals log base 2 of y minus 1. Change it from a log to exponential. So we're going to rewrite it with base of 2. So 2 to the negative x plus 5 equals y minus 1. And then we're going to add 1. So f inverse of x equals 2 to the negative x plus 5 plus 1. So there's your inverse. And lastly, we have the rate of change from 2 to 5. So that's f of 5 minus f of 2 over 5 minus 2. And that would be f of 5 is 3 minus f of 2 is 5 over 5 minus 2. So that would be negative 2 over 3. And we could leave it like that. Okay. Not often does it work out with integer numbers, so that was nice. Okay, so those are the first 4 problems. We'll pick up with another walkthrough video for some of the other problems. If you got questions, please make sure that you're reaching out.